Now let's do the third one. Okay, question number 1, the third one, that is f of x is equal to sine x plus 1. So the first principle formula, f dash of x is equal to limit h tends to 0 f of x plus h minus f of x upon h. Okay, now this is the function f of x sine x plus 1. So f dash of x will be limit h tends to 0. Now replacing x with x plus h, or adding h to x. Okay, so sine x plus h plus 1. Okay, and minus the function as it is, sine x plus 1 upon h. Now if you see, this resembles a formula of the trigonometric formula, that is sine a minus sine b. Now if you consider this to be a and this to be b, then sine a minus sine b, sine a minus sine b, which is equal to 2 cos a plus b upon 2 multiplied by sine a minus b upon 2. Okay, this is the formula. So let's expand this in this way. Okay, let 2 be separately common. So we have limit h tends to 0. So 2 cos a, now this is a. Okay, so x plus h plus 1 plus b, this is b, plus x plus 1. Okay, upon 2 into sine a is this one, x plus h plus 1 minus b is this one, x plus 1, so x plus 1. Okay, let this be in brackets because we have negative here. So upon h, let that h be here. Let's bring it out, 2 upon h. Okay, let's be here. So limit h tends to 0. Now you see, if you add, okay, 2 upon h cos, see you have x and x, so become 2x, 1 and 1 becomes 2, 1 plus 1 2. Okay, so you have cos 2x plus 2 plus h upon 2. Okay, multiplied by sine x plus h plus 1. Let's open the brackets, so it becomes negative x and negative 1. Okay, upon 2. So limit h tends to 0, 2 upon h. So when you distribute this 2 to all these, you have cos 2x upon 2 plus 2 upon 2 plus h upon 2. Okay, sine, you see positive x and negative x, positive 1 and negative 1 goes out, you have h upon 2. Okay, sine, this is the angle of sine. Okay, sine h by 2. Now if you see here, this 2 and 2 goes, it have 1, this 2 and 2 get cancelled, you have x. So you can write limit h tends to 0, 2 upon h cos, this becomes x, plus this becomes 1, plus this becomes h by 2, and this becomes h by 2. Okay, now if you see, this resembles a theorem in the limits, algebra of limits, that is sine x upon x. Okay, where limit x tends to 0, then it's 1. So let's make it in this form. So let's divide by an h by 2 here. Okay, so this will be in this form. So we can write limit h tends to 0, 2 upon h cos x plus 1 plus h by 2. Okay, multiplied by sine h by 2 upon h by 2. When we divide by h by 2, then we have to multiply it also by h by 2 to balance it. Okay, h by 2. Now let's bring this h by 2 out. So it becomes limit h tends to 0, 2 by h multiplied by h by 2 cos x plus 1 plus h by 2 multiplied by sine h by 2 upon h by 2. Okay, now this h and h goes, 2 and 2 goes, so remaining is this. Now you see these are two functions. Okay, so again we have a property, a theorem in the limits, algebra of limits, that is limit x tends to a f of x multiplied by g of x. If two functions are multiplied, then the limit are in, this is called the limit product rule. Okay, the limit can be distributed to the two functions, that is limit x tends to a f of x multiplied by limit x tends to a g of x. Okay, so now this is in this form. Okay, so let's distribute the limit to each separately. So it will be limit h tends to 0 cos x plus 1 plus h by 2 multiplied by limit h tends to 0 sine h by 2 upon h by 2. Okay, now this is exactly in this form. Okay, the theorem. So we can make this, write this as 1. So limit, now putting the value of h in the function here. Okay, in this expression h, so we have cos x plus 1 plus 0 upon 2. Okay, and this will be 1. So this will become 2 zeros, 0 upon 2 is 0. So you have cos x plus 1 and multiplied by 1. Okay, so we have same thing, this multiplied by this is cos x plus 1. So this is the answer. See, we have learned earlier the formulas that d by dx of sine x is equal to cos x. Okay, so here the derivative of sine x plus 1 is cos x plus 1. Okay, now let's do this using the general method, that is the power rule method. Okay, the normal method. So f of x is equal to sine x plus 1, sine x plus 1. Okay, so d by dx of f of x is equal to d by dx of sine x plus 1. See, now we have a new technique or a new rule here which we must learn. Okay, because in further chapters we require that. Okay, in further exercises and all the problems this rule is required. Okay, so that is known as the chain rule. Okay, see, you have the power rule d by dx x power n equal to x raised to n minus 1. Here the variable is a single variable. Okay, what if this x is a linear or a quadratic expression? Like for example, if it's x plus 1, if this x is like 3x plus 1 whole power n. Okay, then d by dx of this will be n exactly in this way, that is n into we'll write it here, n into x. This is x. Okay, this is in place of x, so we write 3x plus 1 whole n minus 1. Okay, since this is not x, because we are assuming this to be in the place of x and writing it as whole. Okay, so since this is not x, we'll derivate this again, multiplied by its derivative. Okay, d by dx of 3x plus 1 again. Okay, this is called chain rule. Okay, so now we'll do this. Okay, come across this in the next problems and all. Okay, we'll see that. Now we have to use this chain rule here. That is, now d by dx of sine x plus 1. Okay, so we know the derivative of sine x is cos, derivative of sine x is cos x. So we'll write the derivative of sine x is cos x plus 1, assuming this to be x. Okay, assuming this to be a single variable, okay, that is x, we write it as cos x plus 1. But since this is not a single variable, this is not x, a single variable, we have to derivate it again and multiply it. That is multiplied by d by dx of x plus 1. Okay, so that is cos x plus 1. Now derivative of x is 1, derivative of 1 is plus 0, 0 plus 1 is 1. Okay, so cos x plus 1 into multiplied by 1, that is cos x plus 1. Okay, this is how it is done, okay, using chain rule. Okay, we'll come across this rule in the for next exercises and the next problems maybe. Okay, we'll see. Okay, that's it.